everybody. We're going to be talking today about security, and particularly what security looks like from the perspective of an open source maintainer. Just to introduce myself a little more, my name is Jason. I've been around the Lucene and Solr communities for a while, and I'm a committer, which in the Apache world means that I can contribute code to a project, and I'm particularly a PMC member, or a member of the project management committee, which is relevant in this context as it's the group of folks in an Apache project that are responsible for kind of handling security reports as they come in and triaging those and getting fixes out there. That's kind of a smaller subset of the community at large. And so I've been a member of the PMC for a number of years. I've worked on security issues that have come up for Solr for much of that time. One last thing is, by way of introduction and almost confession, is that while I'm here giving this talk and you've come to listen to me speak about security, I'm not really here as a security expert. I don't know, I have to frequently Google the difference between a weakness and a vulnerability and an exploit, which are all different terms, it turns out. I don't know the difference between POSTA and STRIDE. Does anybody know what those are? Those are different threat models, apparently, that your project can have. I'm not here for my kind of credentials as a security person. I do have a lot of experience and expertise as an open source developer, though. And so I'm here to talk about what the decision-making process looks like, good or bad, for open source communities out there. And a lot of that is kind of, it's relevant that I'm not a security expert, because we hear the phrase often that security is everyone's responsibility. And if you take that to heart and you understand what that means, if it's everyone's responsibility and only a few folks are actually security experts, the implication of that is that 99% of the security work being done out there is being done by folks who just love their projects, who want to support their projects, whether or not they have security expertise to back that up. And so while I'm not a security expert, I think I have kind of the experience for, my perspective is the perspective of most open source maintainers when it comes to security. So in terms of what we're going to talk about today, we'll talk a little bit about what security looks like at the Apache Software Foundation, which is the foundation that my project exists under. Is anyone here a member of the ASF? Has anyone here worked with security under the ASF? Okay, so at least there's one person that can catch my mistakes when I mess up. Please do so politely. So we'll talk a little bit about what security looks like broadly within the ASF, how things are handled. And then the rest of my talk is divided into two sections. There's kind of challenges, things that make security difficult in the open source world. And if those are our problems, the second half of our talk will be kind of solutions, lessons that my project, the Solr community, has learned through decisions, good and bad, that we've made. Usually bad is how you learn lessons, unfortunately, but things that I want to share with other communities out there, so hopefully folks can avoid making the same mistakes that we've made. So that's going to be our agenda for today. So just by way of introduction to talk about how security works at the Apache Software Foundation, as I mentioned already, security is handled largely by the Project Management Committee, or the PMC, for each project. And so that's a smaller group of folks within the larger community. And reports will come to this group through one of two different mailing lists. Each project has their own project-specific mailing list, which for Solr is, say, security@solr.apache.org. Most of the reports will come in through there. There's also a foundation-wide mailing list that reports come in through. And typically why somebody would use that is if they've sent a report to the project-specific list and it doesn't get a response as quickly as they were hoping. Sometimes folks will use the foundation-wide address if they sent a report and it did get a response, but it wasn't the one they were hoping for. So you get kind of a mix of reports that come in that way. And that's how reports come into our project. From there, there's this process that I imagine looks familiar to most folks out there, where the report comes in, you triage it, you decide what to do with it, and there's one of two major outcomes. Either we're going to reject the report as it's come in. Historically, this, an example of this would be someone submits a report because one of our dependencies has a CVE or a vulnerability, and it turns out that in practice it doesn't impact our software, but their scanner picked it up. So we do a lot of rejections for that. That model started to change a little bit. A lot of the rejections today are because someone has produced a report with an LLM, and that has hallucinated some behavior or misunderstood some behavior for how Solr operates and what the APIs actually allow. So the sorts of things we're rejecting have changed a little bit over time. So that's the rejection path. The alternate path is actually if the report is valid, if there is behavior that needs fixed in Solr. And so that kind of spawns two different operations. The first is that someone from the PMC will try to fix the issue. They'll make a code change, they'll make a configuration change. And at the same time, there's a drafting of a security report. This report is eventually published as what's called a CVE, or a critical vulnerability enumeration. But essentially what this is it's a write-up of what the security concern is, how a user might determine if they're impacted, and how they can remediate the issue, either by upgrading or changing some configuration or something along those lines. And you can see there's kind of a time gap here. The fix goes in, the report is drafted, and then there's a bit of time before it actually goes out into the world when we're able to release the software. And usually the security report, the CVE, doesn't get published until there's actually a release out there that fixes the problem. So there's a time gap in that. So that's just a quick overview for how things work at the ASF. Hopefully, kind of the general process looks similar to how it works under other foundations for other projects, for other companies as well. Now I want to focus a little bit on, given that model, what are some of the challenges that come up when you're doing security in the open source world? And I'm hoping to kind of follow that chart as we triage reports that come in and then start to act on them and then even publish them out into the world. So the first challenge you're going to run into, if you're somebody that has just filed a security vulnerability against Solr, you've just sent your email to these mailing lists, the first problem is just getting seen, unfortunately, at this point. It's kind of a well-documented problem across a number of projects, but the number of security vulnerabilities has really shot through the roof, or at least the number of reports has shot through the roof in recent years. 2023, where this chart starts, was a kind of a banner year for Solr. This was the most vulnerability reports we'd received as a project up until that time. And things have escalated and escalated from there to the point where even just in the first 3 months of this year, you can see we have nearly 4 times the results that we had even just a couple years ago in that entire year span. I believe, I don't have the numbers in front of me, but I believe we were on track to have about 10x what we had in 2023 based on the extrapolation from those Q1 numbers. And so a lot of this is driven by increased awareness. Folks are more interested in security now. A lot of it is driven by LLMs in the AIs that have made a lot of the research and investigation easier and more possible for folks. And that's both good and bad. You get a lot of reports that are maybe less valid, but you get a lot that are honestly surfacing kind of real problems. And so it's a blessing and a curse at the same time. But the first challenge is just getting seen. The second challenge that a report has when it comes into the PMC list and PMC members start to look at it is, I've called it variety here, but really the question is, if you submit a report and that report involves chaining together a couple features in this particular project, are there PMC members around who are reading the security list who understand those features, who understand how that works, who understand it well enough that they can go and reproduce the problem? Oftentimes, open source projects that have existed for 5, 10, 15 years have this extremely broad, varied feature set. And so finding not just a PMC member to read your security report, but the right PMC member who's going to understand that feature and be able to act on it is kind of a challenge as well. The next thing I wanted to talk about, let's say you've submitted your report, it's been seen by the right PMC member, or the right group of PMC members within the project. The next thing I wanted to talk about is kind of the organizational support and the organizational structure that person has as they try to go work on fixing this thing. And the best way that I could to evoke this was to call out the cathedral bazaar image. Ruth mentioned this in her keynote talk. Who was all there for that? So if you're familiar with this image, it's kind of representing the way that software development in a proprietary closed source environment is different from development in an open source world. The idea being that a cathedral or the proprietary closed source model is very heavy on planning. There's a very centralized authority that makes lots of decisions. Whereas the bazaar or a marketplace is very different. Vendors will show up, they'll open their stall, they'll sell whatever they want to sell, and they'll leave. And that kind of matches the volunteer model that open source operates under. Folks will show up and they'll contribute to what they want to contribute to, and there's no kind of governing authority in a lot of senses. And so this kind of has two implications for working on security. The first one that I wanted to call out is in the proprietary model, you have a lot of folks with maybe specialized roles that can pitch in and helping with in any individual report. So if you work for a company and somebody reports a vulnerability in your software, you might have project management prioritize the report. You might have a manager put it into your sprint specifically. If you're a developer, you're going to go fix that. There might be a docs person that helps write the security report that's going to eventually be published. There might be support personnel, or there might be public relations that can kind of liaison with the reporter and go back and forth with them, or publish announcements that go on your website. There are all these different hats that are worn by different people. Not every company is going to have all of those roles, but generally the responsibilities are distributed. In an open source community, that tends to be not impossible, but it's less the case. You see that less. In open source, it seems like fewer people end up wearing more hats. So if you are a PMC member for an Apache project that has picked up a security vulnerability, you're going to have to be good at doing a lot of things. You have to be able to fix the problem technically. You have to do a lot of communication with the reporter. You have to be able to write up the security report. And there's lots of benefits that come from being in an open source environment. You can get lots of review from other folks. There's lots of help. It's easy to get that. But generally, you end up wearing more hats. The second thing I wanted to kind of call out in particular is there's a lack of management or decision-making power in open source communities. And particularly, we talked about management assigning something to somebody's sprint. What you see sometimes in open source communities is that while the PMC or the security team or whoever it is for your project, while they have a general mandate to work on security and make sure things get fixed, there's very rarely an individual mandate for any one person. And so a lot of times what you'll see is that in an upstream community, a security report will come in and it will sit, and maybe a couple people will read it, but then it'll still sit, and it ends up sitting there for quite a while. And that's not due to malice or laziness or anything else. The problem is that people are volunteers and they may be on vacation. They may think that some other volunteer is going to jump in and take care of it because it's right in their wheelhouse, or they're expecting something like that. And so what we end up with in practice is this idea of it's somebody else's problem. Or there's kind of this game of chicken where folks are waiting for someone else to pick up the ticket. And eventually this causes delays, but it is a problem that kind of solves itself over time. Someone will volunteer, they'll take up the ticket in almost all cases. But it does cause delays, and it does kind of leak out into the project in certain other ways. Ruth, in her keynote, made a comment about how pervasive burnout is a problem in open source communities right now. And this, I think, is a big cause of it, because the people that tend to lose this game of chicken, the people that end up picking up these security reports, it tends to be a little unevenly distributed. There's a few people that are doing a lot of the security work, and a lot of people who are doing much less of it. And that can lead to resentment, that can lead to burnout. Anecdotally, I know of a few people who have stepped away from open source communities because they no longer want to be seen as the security person. They don't want the assumption to be that they're going to pick up this thing. So that there's kind of a burnout tie-in with this here. So the next challenge I wanted to raise is that your report has come in, it's been seen by the PMC, it's been seen by the right person on the PMC. The logjam, if there was one, of waiting for someone to actually pick it up and volunteer to work on it has been resolved. But still, the people working on these are volunteers. They have limited time, as we've talked about. They may not be security experts, as we've talked about. But they also don't have sometimes the resources that they need to solve these problems. Particular vulnerabilities might be specific to an operating system. They might be specific to a cloud environment or a Kubernetes cluster or some kind of computing environment that they don't necessarily have access to. Maybe they could get that access, but it would take cloud credits, or it could take money, or it could take a lot of other things that maybe as a volunteer they don't have, or they'd have to spend their own kind of money for. And so a lot of times volunteers don't have the organizational support that they need, even if they're ready and volunteering and willing to take this thing on, to actually reproduce or to test or to do these different things. But let's say we've gotten through all of those challenges and we've gotten to the fix portion, and a fix has gotten in for this report that's come in. There's still one last problem, which is that there's this time gap that we talked about between when the fix is made, when the CVE report is drafted, and when it later gets published. But the problem is that as soon as that fix gets into the, as soon as it gets merged, essentially, there are breadcrumbs there. Even though we haven't published the security report, there are still breadcrumbs pointing to the issue. It's there in the code if anybody wants to look at it. It is in the Git log if somebody wants to look at your commit message. That commit message probably references a Jira ticket or an issue tracker ticket. And so there are all these things that you are expected to communicate because you're developing in the open that may point to someone at this security issue that hasn't been released yet. So this is kind of the contradiction of trying to do secure development while out in the open. And so there's lots of kind of communication challenges that folks run into with this. A lot of projects try to obfuscate the nature of security things, or they'll give a very generic commit message. But there ends up being a lot of ink shed on what the right level of obfuscation is to try to make sure that things are not discernible until the CVE is out, and then once the CVE is out, that there's enough breadcrumbs there that folks can track back and see, okay, I see what this was now. So that's the last challenge that I wanted to highlight in terms of what makes open source security development difficult. Some of those things are kind of frustrating and make the process difficult, and I wanted to end on a more positive note by talking about some lessons that we've learned at Solr that hopefully, if any of you are involved in open source projects, you can take back to your projects and maybe learn from our mistakes and avoid repeating them. So the first, I've given these titles. I don't know that the titles are great. The first lesson that I wanted to highlight is called Unforeseen Consequences, which will make sense when we get through it. So to understand this, it requires a bit of a history lesson, which is in the earlier days of Solr, there was a posture among the community that none of Solr's APIs, none of Solr's functionality was designed to be exposed more broadly. Everything was expected to be behind a firewall. And so when particular vulnerability reports would come in, we had a stance of saying, like, these things are not valid because we expect you to be behind a firewall. That's part of your due diligence and your responsibility. So certain things like cross-site scripting, for instance, were just disallowed. This was from our early reference guide documentation that we offered. And that was a very popular, well-understood stance at the time. But as Solr started to be more popular, it started to have more users at maybe smaller to medium companies, folks really wanted the ability to have kind of better security support than just saying throw it behind a firewall. And so the idea came up around 2015 that we should add authentication and authorization to Solr. And it seems like a great idea. You want to be able to validate that the people making requests are who you think they are. You want to be able to restrict the functionality that they can access to. This seems like an easy win, right? And in a lot of ways it was. So this got added around 2015. It was kind of the base framework was there for either authentication or authorization. And there were a lot of plugins that let people kind of plug in whatever security approach that they wanted. Basic auth was kind of the biggest one right out of the gate. From there, it was 2015, so Hadoop was very popular. So the Hadoop auth plugin was there. The Kerberos auth plugin was there. Later on, we added support for JSON Web Tokens, or JOT, OAuth, a couple different implementations. And these were all great, and they helped people secure their Solrs, and it largely worked. Everything was, it 100% made things more secure. But it had this unintended consequence. which is once this feature was out there, once we were telling people, hey, you can secure your Solr with just this auth, it kind of undermines the security model or the assumption that we'd made before, which was that everything should be behind a firewall. And we started to see that. We started to see reports come in and we would tell people, no, this stuff needs to be behind a firewall. This is your mistake. And people would come back to us and say, what do you mean it has to be behind a firewall? Like, you let us set up authentication on this. Like, that kind of assumes that other folks can reach this thing. And ultimately, those reporters were correct. We'd kind of undermined our own security assumption here. And so as you can see, starting in 2015, in the years that followed, we had to accept a number of cross-site scripting vulnerabilities. Because what we'd seen when we added this feature is we'd accidentally kind of created some scope creep or some drift in what our security model was. And so the lesson learned that I wanted to share is that projects need to be very intentional and careful about guarding their security model. A lot of times this comes up in explicit discussions where somebody proposes a change, but it's even trickier when this is something that happens accidentally, like it did in this example here. So any feature, particularly if it involves security, I think this should be a discussion of, does this change our security model? If so, how? If so, are we okay with that? Another kind of side lesson to learn from this history of Solr is that not only did we end up with CVEs because we had drift in our security model, we had CVEs because we were adding a bunch of authentication and security code that we'd written ourselves. Not only is it a drift in the model, but it's this whole additional surface area that we'd added to Solr. And so we see CVEs in our Kerberos plugin, in our Hadoop plugin, in our PKI. This is how Solr kind of authenticates requests between nodes in the larger cluster. We've had CVEs as recently as this year in our authorization plugin. It's been this thing that has undoubtedly been an improvement in terms of giving folks more options to secure their cluster, but it's resulted for the Solr community in a bunch of additional work and CVEs and releases. And so looking back at how this feature was developed, there was a comment around 2015 where someone pointed out that, like, hey, we probably shouldn't be writing all of this code. All of these features we're adding right now, they're out there in existing frameworks, and they're developed by teams like Apache Shiro or Spring Security, where their main job is getting the security stuff right. We should use one of those. We don't want to be maintaining Kerberos code in Solr itself. And ultimately, we did not listen to this comment that came in around that time. Bonus points after the talk if anybody can guess who this was that said this. But they end up looking kind of prophetic in hindsight because we've had all of these CVE issues after the fact. So the other lesson learned here that I wanted to highlight, I think it's one that everyone probably knows, but it's a problem that's incredibly easy to fall into, is that always, if you have the opportunity, use a high-quality off-the-shelf alternative instead of writing things yourself. That's something we've struggled with in Solr, I would say. So the next little lesson learned that I wanted to share here is called hotspots. In Solr, what we've seen kind of in our history is that we develop a lot of features that try to be a lot of things to a lot of people. We try to make features very flexible. And with those flexible features, what we tend to see is that they end up with a lot of CVEs. So one example of this is it gets called the lib directive if you're ever on the mailing list or in our documentation. Essentially what it is we have an XML configuration file, and this allows people to point to external jars if they want to load a plugin or something like that. And this is great. It gets used by a lot of people. People loved it. But the problem is that it ended up causing a lot of security vulnerabilities. It's a very hard thing to do securely. Another example of this is called DIH, or the Data Import Handler. This is a feature that Solr had at one point that allowed folks to take their data that was in a SQL database and kind of export it to Solr. And it started out relatively simple, and it expanded to cover additional databases. It expanded to do kind of delta imports and these other things. And the pattern here, where we see this spread of vulnerabilities over time, is particularly concerning, because you can go back to the security vulnerability report from 2018, and it's pretty clear from looking at that discussion that we thought we had solved this problem in 2018. There was this sense of like, oh, we've locked this down now. This will be secure. And you read the report from 2019, and it's the same thing. You read the report from 2021. Surely we've locked this down this time. So particularly with this spread of vulnerabilities through time, what you end up with here, and with the lib feature as well, is these are two features that users really liked. They provided a lot of flexibility to them. They let them use Solr for their use case. And so there's a lot of user value. But on the other hand, there's this kind of history going across years where we've showed that either through lack of expertise or lack of contributor interest or lack of willpower or whatever it is, there's user value here, but we have shown an inability to secure this feature. And so as a community, you're kind of faced with this question. What do you do when people are using this feature, they love it, but the PMC or the folks that are paying attention to security know that it's likely a ticking time bomb in some ways. And of course, this is a very situational thing for different projects, depending on what the feature is, depending on what the details are. But one option that has to be on the table is removal. And so ultimately, that's what the Solr project did here with these two features we've talked about, with DIH and with the lib directive, is they were slowly kind of phased out of Solr. And ultimately, the biggest hurdle with doing that is kind of building consensus in the community for this, because you have folks on your users list or your user base who love these features, who don't know that they've been compromised by them, that the flexibility allows them to use Solr. And you have the people on the PMC list who see this from a totally different perspective because they're familiar with the past history of security issues. And so there's a lot of community work that needs to be done to kind of communicate why this is being removed and what people can do instead. The last lesson learned I wanted to communicate, I'll call security difficulty. This is all about making the ways that contributors make, the way that code contributions come in as secure as possible. Making it easy for coders to code securely, maybe a better way to put it. This is a little code snippet from Solr. We have, Solr is very kind of file I/O heavy. We do a lot of reading and writing from files on disk. And so it's a big concern of ours in Solr to make sure that folks are only reading and writing the files that they should be allowed to access. And so Solr has a mechanism for handling this where we allow folks to specify a list of places that you should be allowed to read from. And so a lot of places in Solr, you see code snippets like this, where first we check whether a particular file location is allowable or acceptable. Does it kind of fit what the administrators have said should be acceptable? And only then do you go and open the file and do something with it, right? Does anyone want to take a guess with what the problem with this snippet is? Go ahead.
What's a specific behavior regarding files, like certain links and backends?
Yes, that is a problem. So the suggestion from the audience is that a lot of times there's OS-specific behavior in terms of how file paths are handled. And that is an issue we have run into in Solr quite a bit. It's not the one I was going to focus on, but it is a absolutely correct solution or answer. The other problem with this snippet is that even assuming this assert path allowed method has the correct behavior, it treats file systems differently and in a correct way, the problem with this file snippet is somebody has to remember to put it there in the first place. It's a problem with remembering that it needs to be there. If you think of any kind of complex system like Solr, where we're doing lots of file I/O, there are probably hundreds, thousands of places where we talk to files. And you are requiring, with the solution that we have in place here, we're relying that every single place we do that, somebody remembers to put this first line before the second. And a lot of cases, that has not been true in Solr. We've received a number of vulnerabilities in CVEs and reports because inevitably, someone forgets to do this. We have a new contributor come in, they're not familiar with our process and the issues we've had in the past. They're just offering a PR. And so we've set up a protection in a system that requires kind of perfection from our contributors, which is totally unrealistic. And it expects perfection of our reviewers too. And so the the lesson learned that I want to highlight here is to choose protections, whether they be kind of security model or code policy or what have you, that don't expect perfection from your developers, from your contributors. Because if it's going to be perfection or nothing, it'll be nothing every time. There will always be some place where this is forgotten or missed. So that's kind of the lessons learned that I had that I wanted to share. I'm happy to take questions. I'm also curious to hear of lessons learned that other folks have run into if they are involved in other projects that have run into these sorts of things. So that's what I've got. Happy to take questions.
You mentioned earlier on obfuscating your pull request. I mean, do you actually even believe that that's a viable strategy nowadays? I mean, if I was a badly behaved person with access to tokens, I would be just squatting on everybody's PR request and reverse engineering whether there's any vulnerability. I mean, I don't think you can get away with that at the moment. So,
the short answer is no, we do not believe it does anything, but we still try to do it anyway. So I agree with you.
Okay, so question. So you're hiding it from probably naive, well-behaved humans, but you're not hiding it from the machines or people who with bad intent. This looks like the worst possible outcome. Without, I am putting you on the spot, so you don't have to answer that in this. But I mean, I don't think that's the right way of dealing with this problem.
It's certainly not a great solution, but I think while we're maintaining this delay between when the CVE is published, like that's still the intent largely for a lot of folks that do security, is there needs to be this delay between fix and publication of the CVE. While we are kind of still doing that delay, I think we're just trying to maintain consistency with that.
So why didn't you just embargo it and not make it public?
Can you elaborate on that? Sorry.
Well, I mean, you don't let AI see your work in progress.
So don't.
I mean, you're going to have to do the fix, but if you need to release the CVE and do the push.
You're saying like have the person that does the release merge the fix right before they do the release. Is that the idea?
Yes. Yes.
Okay. Yeah, there's also the problem with how the release works in Apache. So it takes a few days, at least 72 hours. And I think there's no easy way to circumvent that somehow. And that's a problem. So you could push the commit at some point, and then it still takes a few days.
Right.
But I think we have seen the same issues now with recent problems in the Linux kernel. So there were some hidden, as you said, some hidden commits which did not explain what's happening, but somebody analyzed it and figured out, that's what's going on there. And then we had all those every time the same type of 0-day exploits. So basically, there's no way. If you do it open, you also need to do the voting close. So maybe the release branch needs to be completely hidden before it's released. But I'm not sure if that's not yet solved. I think in the open source,
it has kind of a domino effect of what it starts to impact. As soon as you want to like put the commits in very late, then a lot of other stuff has to be closed as well.
So one more question, maybe?
Also, I mean, just to add to that, I would say that the approach of obfuscating is something that doesn't work as well like now after the advent of AI and all of those things, right? I mean, it has served as a decent barrier when it was a manual process all this while, and so this is I mean, you could obviously improve it from here on, but that doesn't, in my opinion, mean that there is zero value to it in that sense.
You should just move to the front of the room.
Sorry, yeah. I mean, look, it looks like the worst of all worlds, right? If you're not alarming the community, the users, the good folks about what's going on because you're obfuscating it, right? Which makes it obfuscate, but you can't do security by obfuscation in the time of AI, right? You're giving a pass to people who are focusing their time, effort, and resources on being bad, and you're not giving a heads up to the people who are actually just trying to get their day jobs done.
Yeah, I get it.
I understand you get it, right? I'm not, but the point is, we got to come up with better solutions for this. We can't just go, we're doing it because this is the only way that we could figure out how to do it, right? I mean, the answer's clearly not the right answer. It's suboptimal, very suboptimal. So let's talk about how to be better than suboptimal, would be my suggestion, right? And
Sure.
You may have to change your policies. You may have to change a whole bunch of things, right? But reality is catching up with us.
Yeah.
So, end of comment.
Yeah, so thank you for the comments, questions, remarks, and of course, thank you, Jason.